In this video, we're going to look at integrating exponentials and logs using U-Substitution. For our first example, we're looking at evaluating the integral from 1 to 3 of e to the x squared times x dx. The first decision we need to make using U-Substitution is what to set u equal to. So we're going to set u equal to x squared, because the derivative du equals 2x dx is similar to this x dx term in the original integral. We can actually get this exact x dx term by dividing this equation for du by 2 on both sides. So we get that x dx is equal to du over 2. So now we can substitute our u in for x squared in the original integral and du over 2 in for x dx in the original integral. We also need to change the bounds. Since the original bounds, the 1 and 3, are in terms of x, and our integral is now in terms of u, we need to plug our bounds into the equation u equals x squared to get our bounds in terms of u. So our new bounds and our integral looks like 1 squared to 3 squared of e to the u du over 2. Since the 1/2 is a constant, we can evaluate this as 1/2 e to the u from 1 to 9, and then plugging in our bounds, we get a final answer of 1/2 e to the 9th minus e to the 1st. Let's look at another example. If we're asked to evaluate the integral from 4 to 5 of 1 over 3x minus 2 dx, again we need to decide what to set u equal to. We're going to make u equal to the denominator, 3x minus 2. Calculating the derivative, we get du is equal to 3 dx. Since again we only have this dx term, we're going to divide both sides of this equation by 3, and we get that du over 3 is equal to dx. Now let's calculate our bounds in terms of u. For our lower bound, x equals 4, we're going to plug this into our equation for u. So we get u is equal to 3 times 4 minus 2 equals 10. So our new lower bound in terms of u is 10. For our upper bound, x equals 5, we get u is equal to 3 times 5 minus 2, which is 13. So our new upper bound is 13. Putting this all together, our new problem, we have to evaluate the integral from 10 to 13 of 1 over u du over 3. Since, again, the 1/3 term is a constant, the integral evaluates to 1/3 times the natural log of u, evaluated from 10 to 13. We then plug in our bounds and solve, and our final answer is 1/3 times the natural log of 13 minus the natural log of 10.